Hi everyone, and welcome to our video on drawing a graph based on some given conditions. So in this problem, first thing I want to do, so I think I made a typo. So let's read it first and I'll show you why. So it says draw a graph that has a horizontal tangent line at x equals 5. Okay, so there's the first thing that's important or that they want out of it. And I'm just going to move the little blinker. Okay, so there we are. All right, and then it says continuous on 0 to infinity. Okay, so that's number 2. And then they say not differentiable at x equals 7. Okay, so that's the third thing they want. And then they say it's discontinuous at x equals -2. Okay, well, if it's continuous on 0 to infinity, it can't be continuous at x equals -2 anyway. Okay, so that I think I didn't mean to actually put in, and I'm just crossing it out now. Again, in case you have these notes, I'm going to change that to be just these 3 things next time. Okay, so some typos along the way, we fix them. All right, anyway, so now that we've got it all set up, or we've read it, all we do is we just make a graph. Any graph that we really want, as long as those 3 things are satisfied. Okay, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 to the right, and then just 1, 2 to the left. Okay, because with number 2, it says it needs to be continuous on 0 to infinity. Notice with the parenthesis there, we either need an open dot or an asymptote at x equals 0. Okay, so it's up to us. So our answers can vary. Now I'm just going to do an open dot. That's a little easier to draw. I'm just going to put it right here. There's my open dot. And then continuous on 0 to infinity means it needs to go to the right somehow, like that. Okay, and then it also doesn't matter the order we do these in, as long as they're all going to be satisfied at the end. So we'll go back and double check. All right, a horizontal tangent line. So I don't think we've seen this yet in any video. I'm going to go back up. So these ones I had written on if you were following these notes. However, all I want to do is just point out how they come about. Okay, so on like this previous problem, again, that was already marked. But following a curve, if I were to continue following it, and if I get to a peak, so I'm just going to mark it in the blue, that's where a horizontal tangent line would come in. Okay, so you don't need to redraw anything. I just wanted to use this as an example. So right here, I think it would be messy on our previous one, but that's also where a horizontal tangent line would be. Okay, so they occur at the curvy peaks. So at those top or bottom, it doesn't matter. It's where it has a curvy peak to it. So this one doesn't have any horizontal tangent lines because that's a pointy peak, so it doesn't have a tangent line there. Okay, so it's just making sure we have a curvy type of peak. All right, so at x equals 5, so 1, 2, 3, 4, 5, I'm just going to put that, I put a dot there to say, all right, I want there to be a curvy peak. So I'm just going to go up and then turn around. There we go. Okay, so that would make it to where I have a horizontal tangent line at x equals 5. There we go. So that's the horizontal tangent line at x equals 5. Okay, so I think that's so far so good. And then it wants us to have something that's not differentiable at x equals 7. Okay, so 1, 2, 3, 4, 5, 6, 7. I see it. All right, so if it's not differentiable, that means it has to be one of these 3. Well, it says it is continuous, so I can't just put an open dot or an asymptote. So it looks like I should do a sharp corner, so a wedge or a cusp, or I should make a vertical tangent line. Okay, so I need a wedge slash cusp or vertical tangent line. So again, we have our options. It just wants any type of graph. As long as it satisfies these 3, well, I'm going to do the wedge or cusp. I think that's easier. So I've got 1, 2, 3, 4, 5, 6, 7. I'm just going to put a dot here and then head to it and make a sharp corner. So there's a wedge. And then now I'm just putting an arrow at the end to make sure it stays continuous. So this is just saying, yeah, it keeps going. And we're assuming there's no other problem. All right, and then that's it. Let's just double check real quick. All right, so are all of these three satisfied? So I can have other crazier stuff going on if I really wanted to, as long as these three are satisfied. Okay, so continuous on 0 to infinity. Yep. Okay, so it starts at 0, open dot, and then it goes to the right forever without lifting our pencil. Is there a horizontal tangent line at x equals 5? Oh yeah, good. And then is it not differentiable at x equals 7? Well, I put a cusp there. Okay, so it's that one. And so, yep, good. Okay, so that's that. Okay, so sorry for the typo on that part, but that is it. If you do have any questions, please let me know. Otherwise, thanks for watching.